Welcome to the SNIA Experts on Data podcast. Each episode highlights key technologies related to data.
All right, welcome to the SNIA Experts on Data podcast. My name is Eric Wright. I'm the Chief Content Officer and podcaster in residence here with GTM Delta and the SNIA Experts on Data podcast. Super excited today because I'm blessed to be joined by Rita Wouhaybi, who has been somebody who, looking at your impact on the industry and folks that we share connections with, it's great to be able to chat. You've got such an exciting story, lots of background with SNIA and all things technology. So Rita, if you want to just do a quick introduction for folks that are new to you, and then we'll talk about, I'll say it's, as AI comes in, everything old is new again. And there's a lot of interesting things about how storage and memory and compute is changing, but it's actually kind of just coming back around.
Yeah, thanks, Eric, for the intro. It's great to be here today. I am excited for our chat. My name, like you said, is Rita Wouhaybi. I am an AI fellow at Solidigm. I have been doing things in AI for decades before it was cool. I'll date myself when it was called neural networks, and everybody thought that it overpromised and underdelivered. So I'm excited to be here. For the last 8 years or so, before I was at Intel and now at Solidigm, I have been focused on AI software, especially at the edge. And I started this journey looking at manufacturing as one of the domains or market segments where edge AI is transforming what is happening. And it still is such an amazing journey and really a humbling experience when, I came in as an AI expert and factories started opening their doors for me, such as Audi manufacturing. And I learned a lot from them, and I'm really honored. And I can't tell you how excited at being able to help and make such an impact in how people produce products to be, more green, more efficient, smarter, higher quality, and so on.
Well, that really, I tell you, is such a beautiful thing to remember that we often forget when we talk about technology. As the line from *Halt and Catch Fire* goes, computers aren't the thing; they're the thing that gets you to the thing. And AI, as you said, like when you began your journey in that world and is starting with academia, it wasn't known as AI, and we often AI wash a lot of stuff that's going on. Now it's, now with 100% more AI is the new sticker that we slap on every piece of software. And that's, I believe it's normal as part of the industry that we will capture marketing momentum from the excitement around it. And then it also creates the fun part, as we know in some of the analyst world, we call it the trough of disillusionment, where people, all these AI sounding startups or labeled startups come out. And then we realize like natural consolidation then begins in the industry. And we saw even edge, when you described like just the phrase edge, we sort of struggled with even how to define what it really is. But I think we've settled that it was originally seen, people thought like, oh, you're going to run, full large scale compute, on small devices. Like it's impossible. You're like, well, we've actually developed a lot of hardware capabilities that allow us to run at extremely low power CPUs and memory footprints and the amount of sort of line speeds we can gather both on board and off board. They've come a long way. So I think this is why this recycling of ideas lets us go back to first principles of like, what are we trying to achieve? Because if we just look at it incrementally, faster horses, et cetera, all the, the sayings we know. But if you actually say it, at each generation, we go back to first principles. It's such a beautiful opportunity to now say, we've had so many changes that now we can do things we never thought we could do because of an amalgam of innovation that's occurred. So I'll say, Rita, today, what do you see as some of the greatest enabling factors that put AI onto the forefront?
Yeah, a lot of things are happening that are super exciting in AI. Every day, somebody from my team pings me and says, "Hey, you know, what do you think? I found this new thing." And it's like, oh, how exciting that is. So there is the amount of innovation that's happening in AI is just amazing. And honestly, I know this is overused, but that's okay. I'm going to use it. AI is still in its infancy. We're still going to find a lot of cool things to do. And it's going to grow in ways that we are not expecting it today. Whoever tells you I have the crystal ball and I'm going to predict things, I think 99.99% chance they're wrong. So that's part of the excitement. As a matter of fact, I was talking to a colleague the other day, and he is new to AI. And he asked me, he says, "So Rita, I mean, the AI engineers, why are they different than software engineers? They're software engineers. And I can, interchange them with software engineers. What do you think?" And I said, no. big mistake. First of all, and that actually gives you a perspective of what's happening in AI. And then I'll circle back. I know you want specifics from me, so I'll circle back to that. But to a large extent, if we start thinking of AI as just software, we are not paying enough attention. And that's what I told my colleague in a little bit, more diplomatic words. And I actually even did the analogy. I said, my engineers, my AI engineers, my data scientists, my, AI software developers are on a treadmill, and we are running as fast as we can on this treadmill. And I have noticed that the successful individuals who are driving a lot of the AI innovation love being on the treadmill. They are like the crazy people you watch in the neighborhood at 5 a.m. when it's freezing cold, putting on all their clothing and going out for a run. That's what they love to do. So if you start thinking of them as just general purpose software engineers, you will lose them. And it's not just about pay. It's about being part of that innovation and those new things that are getting created every day. So speaking of new things, I am not different from a lot of people. Obviously, LLMs and Gen AI are super exciting. I am excited about them for some applications that are starting to become more popular, but it's not what most people think about. And that is they have two abilities that we have not exposed to the full yet. The first one is the ability to predict things in general. If you think about it, what LLM is doing when you prompt it is trying to predict what a very knowledgeable human based on the data would have said to you, right? So it's that next token. What if my next token is not predicting chatting to a human or writing a piece of code or generating an image? What if it's something like, is this device is going to fail? What is the weather forecast, right? And historically, they weren't that great at any number manipulation, but that is changing rapidly these days. So I'm excited about this ability. That's one of the things. The second one is, us as humans, we are super duper lazy. We sometimes like to hoard things and then we can't find them. And that is so accurate with the data. And as technology has gotten very easy where we can generate data at a way more rapid rate than we can consume it or even know what to do with it or even understand what is this data. We are right now sinking in data. There's a lot of data islands that people can't reach. And LLMs to a large extent, or, in general, not just LLMs, but transformer technologies and other techniques that are growing out of that area is going to get to a point where it help us find our data even before we say we're looking for something. Anticipate some of our needs, bring in some of this data in front of us in ways that we are able to consume it. When, LLM last year started making the big splash, I was at a manufacturing event, and many of the customers, many of the factories, what we call end users, right? Factories, came in to me, and I was sitting on a panel, and, I made some very strong opinions. As you can tell, I'm very opinionated. So they came in later to me and they wanted to chat more. And there was a common theme. And this common theme is that these people are very worried that they're going to miss out on this innovation called LLM if they keep just hiding their data, right? If they keep doing this to their data, they're going to miss out.
Right.
Yet their abilities to collect more data is growing at a rapid rate. And I think there is a lot of anxiety that once they collect this data, what do they do with it? A few years back when I was at Intel, I was called into an executive meeting one time, and I was asked to answer they brought me in to answer some questions related to data and data management. And one of the execs who retired since then says, Rita, data is the new oil. I saw it on the Economist front page. And I was like, oh, data is not the new oil. Data is more like water, right? It's a byproduct of so many things. You get it, and it's really hard to move. It's heavy. You need to figure out how to deal with it. And if you store it for very long, it starts to smell funny. So this is not the new oil. All by itself is not going to give you a lot of money and a lot of value. But like water, if you use it right, you get a lot of amazing things out of it. You get life from it. So to me, that's really crucial. And how we deal with our data and how we're able to digest it is going to become very, very challenging, and even more challenging than it is right now.
If you think about the interesting thing you brought up there is the idea that a software engineer doing AI it's not sort of we're just to slide you over here and change your title. It's a combination, number one, of sort of like obviously general knowledge and skill set, but beyond just the programming language itself, I would say the discipline is now much more cross-discipline, right? Because you have to understand much more about it, including almost sort of networking and storage and memory. We used to not have to worry about packing too much, in memory. We had the idea of in-memory databases. We had some specialists that worked on how do we use that for queues. And so we started to leverage those things, but it was never thought of like how much we really want to maintain in memory. It was like, let's just get it as quickly as possible, flush it. But it was a great way to have transition space for that, or, fast processing for really interesting thing. Really neat stuff that happened around eviction algorithms, lots of neat stuff that's still innovating today. I mean, I see patents weekly on like new methodologies for eviction and optimization. But now we have this incredibly new pattern that even AI itself doesn't have a pattern. It has a plethora of patterns about training and ingestion and, transforming. And so let's talk about the impact on the people, but then what are we doing at the technology layer that's really going to shake things up?
I don't know if anyone ever said that to you, Eric, but you have a skill set where when you're talking, you're wanting me to talk about so many things. So you're making me want to talk about so many different things. So that's great. I'm glad how we're running this conversation. So many things you said that I would like actually to, build on. I'm going to choose a couple, and then if you have additional questions, let me know.
Yeah.
It's interesting that you're talking about networking and memory and the intelligence more than just AI itself, right? AI is changing how compute looks like. As a matter of fact, right before I left Intel, I had a very awesome debate with an awesome colleague of mine, and he was super excited about taking some of those large models and getting very creative and crazy about how you divide it to fit on multiple devices so that you can parallelize it. And I basically decided to take a very provocative stand, and I said, that's never going to work. It's never going to work because it reminds me when I was pursuing my PhD, when some of the smartest people in computer science were pursuing a problem called multi-threading. And I remember I would go attend, I was going for my PhD at Columbia, and Columbia in the city of New York would attract a lot of people who would come in about to graduate and give talks. And they were sometimes job talks, sometimes they were just practice for a job talk. So about to graduate. And we got actually a plethora of folks who are unbelievably unbelievably smart, way smarter than I am, that would come in and discuss these amazing ideas about multi-threading and how you can get sophisticated, and literally PhDs were created based on multi-threading. And then what happened? We kind of, as a community, shelved multi-threading under the carpet and instead said, well, let's do container and concurrency in different ways and solve that problem with different ways, with different assumptions. And if you think about it from a technology and intellectual perspective, multi-threading is superior, right? I mean, again, I've never been in awe with containers. Like, the concept is simple, right? You can't be, I mean, I love it. I use it every day.
It's like when people say, they're like, oh, it'll make it faster. You're like, no, it's literally impossible. Everything, your abstraction layer you put on is degrading performance. It's like saying that shampoo is good for your hair. No, it's not.
I mean, it works, right? It works.
It does.
I think the key concept, the difference between something like multi-threading, which is technologically a superior software solution, rather than containers, which is almost a hack, right? It's a packaging hack, is the fact that all the software that have been built doesn't need to be rebuilt.
Right.
And that is not trivial. So I'm going to go back about the hardware. It's interesting that you said, hey, the innovation is happening all over the place. I would argue that some of the most interesting innovation from going back to the fundamentals started happening in networking. And that is the day when the smart NIC came to appear, and then the DPU. Because what happened there? Basically, the networking folks said, why would I just send the packets to the CPU if I can do something smart with it ahead of time? I can improve the efficiency. And they kind of, for the first time, bifurcated the CPU being at the center of the universe and said, I'm going to do something interesting here. And I think we're going to see more and more of that, right? Not just in the network, because the network will be able, if I have a very smart network and a bunch of compute nodes, I can divide a very large network, a very large deep learning network, completely transparently to the software. Software doesn't even know that it's actually running on multiple nodes. They will all look like one big block, right? So I think compute is becoming more prevalent and across all the pieces in the network, whether it's, the NIC, the switch, the hub, the whatever sophistication, the DPU, whatever we're calling out, whether it's in storage, whether it's in different kinds of compute node that can run particular tasks faster. It's a GPU, it's an FPGA, it's a DSP accelerator. Like, we're going to see a lot of diversification. It's a TPU, right? There is so much amazing innovation happening. But also some of the innovation is starting by saying, I can add intelligence across my entire pipeline. I don't have to, put all the intelligence in one place and then just serve the intelligence. I can actually distribute it. And that brings me back to the edge to a large extent. One of the reasons why I got so obsessed with the concept of edge a few years ago is the fact that the concept of edge breaks down some of the fundamental assumptions that we have had for decades in AI, right? For decades in AI, we said, in order to train a model, in order to do anything interesting, or a node, right, somewhere, has to have full knowledge of the data, full knowledge of the problem, has to have the full data set, right? I can't hide things from it. It cannot happen in a distributed fashion. They all sit in one place, and then I can solve the problem. And that's okay. Sometimes we have to make those assumptions. What edge is doing today is saying, well, what if you don't? What if your compute is not in one place? I was having some conversations with my boss a couple of weeks ago, and I said to him, as a community, us computer scientists, we spend the last several decades moving data to compute, going to the cloud. And right now we're swinging the other way. We're moving compute and distributing it back to the data. But that's not just a simple location move, right? Because again, what does it mean to train on data that is fully distributed? and then be able to act on it locally without the full knowledge and without even the full access to all the compute. So anyway, so many things happening that are exciting in this space that, at first, you're right. Like people at first thought, well, do I bring big compute down and that's how I do edge? Or do I, trim the software and optimize it so that I can run it on lesser compute? But in reality, the use cases and how people actually, value this work. Because if I don't have someone who's valuing it, I might as well not do it. How they value it is actually pushing the boundaries and having us go back to the drawing board and say, well, I no longer have access to all the data. What do I do now?
And the interesting thing is, like, I'll say, like, this is what we used to think is edge, right. Forgetting that this is edge, right? Edge is a place at which you, or like I'll say it's a form factor or a distribution factor, really, in that. And also the hardware capabilities. When we first said edge, this type of thing, a small ICB, a small Pi or Arduino, we consider that like, oh, it's going to be something that's hanging on a telephone tower. And it's like, well, what about the one that's in your pocket?
Well, edge is actually way more diversified than that. So yeah. I held those beliefs until, like I was saying, I got humbled by factories. I remember one of my trips, and I'll use Audi because they went public on the fact that we did a lot of work with them. So I'll use them as an example. And what I'm going to say is not confidential. Like if you look up online, you'll find this information quite easily. If you go to a factory floor today and you open, if they are kind enough to let you open that cabinet, right? Because these machinery will look like cabinets, like metal cabinets. If you open the cabinet that is the robotic controller, you'll find that this robotic controller is actually almost a mini rack of servers inside. Right. You got, hefty CPUs, you got GPUs, you got some ARM controllers that are controlling, the different joints and motors and levers in a robotic arm. So it is sometimes a lot of compute. I don't think it's only, your phone and, a smart camera.
Right. Yeah.
Those are all interesting, but there is a lot of edge that has enough compute, has quite a bit of compute. But I think what's interesting about it is that the data is localized. Many times you have real-time requirements. Like I can have a robotic arm hanging in open space, waiting for a decision to come back from the cloud. Like that's not acceptable.
I guess if I think of I'm trying to think in my head of like, what's the easiest way to explain it? I'd say the edge is being closer to the task. Not necessarily compute data, whatever it is. There are other things, but by saying that it has to be closer to data, closer to CPU, closer to GPU. It's more that it's closer to the activity, and we've done other things to enable that. But it's it is such an interesting thing.
I don't disagree with your definition. There is another one that I like to use because it's that simple. And that is, if it is on-prem, if it is any campus, I'm going to call it edge. It could be an on-prem data center, a rack of servers. It doesn't matter. It still has a lot of properties of being, local, having real-time requirements in many cases.
Right.
Doesn't have access to all the data and so on. So I think from the AI perspective in many of these applications, the on-prem boundary is super simple and actually works in the huge majority of use cases. So that's what I have used. And then there is a spectrum there, right? There is from the rack of servers to the hefty robotic controller, or even stuff that sit in an MRI machine, to little, tiny sensors, to smart cameras. And as compute is becoming more powerful and more specialized, we're seeing lots of innovation. The cameras that I started seeing in 2023 and 2024 as smart cameras are able to run a good part of your pipeline now. And we were doing a use case with a European partner. And as you know, privacy is very big in Europe. So we were able to actually blur all the faces. It came as a setting on the camera using AI. And it worked beautifully. It didn't blur the hands. It just blurred the faces. And we're like, whoa, okay, 2 thumbs up. I can do that. So really intelligence is getting across the entire spectrum from, the far edge super light devices to hefty things on-prem to the network infrastructure and the cloud, which is exciting, really exciting to be part of, this big wave of innovation.
Yeah. Now for the people side now, as a new practitioner coming in, you've seen waves, I've seen waves. I've been at this for a while, as the frown lines around my eyes and my grayish hair tend to tell that I've spent too many hours in a data center over my years. But part of what I learned as an architect was talk to every team, understand every connection, understand every impact, understand the business impact most of all. Now, as a new software developer coming into the world and saying like, hey, I want to explore AI, what are the other factors and other sort of areas of study that you would tell folks that they should explore around creating true sort of like optimized enterprise scalable AI as a first principle?
I think I'm a little bit of a rebel, right? In the sense that I don't know, I disagree with many people who are now feeling that there is a threat on education with AI and, you have to stay within the roots. I actually, remember when I was a teenager and wanted to use a calculator, my dad getting really mad at me. It's like, look at us right now. It's like, no one cares that I can multiply numbers in my head. Honestly, I think it was a waste of time. And I think education at all of this level, not just for software engineers, is going to change. However, one thing remains really, really important, and it's a common thread. And that is be inquisitive and get your hands dirty. I think those are the two skill sets that any software engineer or any person really should adopt. Now, for AI and software engineering, it's more so because, again, things are moving very, very quickly these days. But these remain very true. Be inquisitive. Keep up. Read things. Whatever I'm going to tell you as an advice today, right? Go look at this new version of Llama or whatever it is, or that paper from OpenAI that talks about general intelligence. Yeah. I mean, those are going to have an expiration date. Whatever advice I'm gonna give right now. Versus my advice should be keep up with these technologies as they're changing. Be humble. Be inquisitive, ask people around you what they're doing, and then try things with your own hands. That's how you learn, right? I think one of the most times I've learned is when I stayed up till 3 a.m. trying to fix a bug. And then found that bug and fixed it and, went to sleep and didn't sleep well because I was still all hyped up about it. So, I mean, this is how you get your best learning, is by getting your hands dirty. And getting your hands dirty is going to change because now we have at our disposal things like Copilot. We have the, 70 billion and 100 billion and 400 billion parameter LLM. So how do we work with them is going to be different. But yeah, I mean, I think those are the two things. The other one that served me well over the years is to be flexible. Sometimes, it's a little bit of a random walk to get to your destination and what gets you excited. When I finished my master's degree, I had taken all the classes on neural networks and published in this space, and I was very excited to find a job. And I went on the job market between, master's and PhD, and everybody thought I was weirdo for even talking about neural networks. So I switched to computer networking. Actually, joined a startup for 5 years in computer networking, and I learned a lot. I learned tons of things, right? I can probably still configure a Cisco router while half asleep. And then, I went back to my PhD, and, AI was starting to gain popularity. So it's about, being flexible and learning from different domains and widening your horizon. And again, getting your hands dirty, I think, is very important. I chat with a lot of engineers who read stuff but never try it themselves. It's like,
right.
Give it a shot. Try it.
Yeah, it's like reading 100 self-help books but never applying a practice from it.
Yes.
Like we can consume a lot of potentially meaningful information, but until it's actually enacted or tested, it allows you to sort of find your own edges. Now, thinking about SNIA, in like it's funny to see the practice areas that we see sort of like they're very, it's like network, security, storage, memory, cloud, HPC. There were things that started to develop. And then as we hit HPC, it was like, well, HPC is really storage, memory, networking. Like, okay, cool. It's a few different things. And then suddenly security had to get invited to every working group because you're like, well, there's security everywhere. And then it was like, oh, then there's programmability. And then there's, swordfish integrate, like all of these different layers. And suddenly we realized we are a community of a town of people which have different community centers in which we gather for different sports. But the same players may play volleyball and basketball. They play maybe understanding memory and understanding, networking, and then understanding, threading and distributed systems. And so we see all these things. So what I found is SNIA as a community is the fact that I can go and I can find amazing folks like yourself and other folks that are practitioners of all sorts of different areas working at some of the deepest, coolest R&D, and then be able to evangelize and socialize like ideas and ask questions. Like you said, this curiosity is what allows it. So when you look at, folks that we know in our peer group in the SNIA community, and what is the advantage as a human, to be among those people and those communities?
Oh, tremendous. Absolutely tremendous. There is a lot of power, obviously, in, talking to your own community. They teach you a lot of things related to you, but then there is even more power talking to people who are different than you. And I actually want to touch on a couple of things. So years ago, I was a fairly new engineer who joined Intel, and coming with a PhD to Intel, obviously I had some pent up energy when I wanted to write papers, right? But in the industry as a researcher, it's not like academia. You don't write as many papers. So one of my mentors one day said, Rita, why don't you write patents instead? And I was like, yeah, I could do that. And then I started writing some. And then all of a sudden, the patent group invites me to a harvest session. They used to call them think tanks. And they teamed me up with 3 other individuals. One was a security guy. One was mobile, cell phone and mobile devices. And the third guy was very much cloud guy. And at that point in time, I was interested in writing recommender systems, and I was like down the rabbit hole of AI. And I was so pissed at first. I was like, why would they do this? Like, I have nothing in common with those guys. And it was amazing. The 4 of us, I think, ended up writing more than 50 patents together. Wow. And it was like the riffing on each other's, because I was so hesitant at first. I was like really stupid and perhaps a little arrogant. I didn't even want to share my ideas. And then I shared one, and they were like, oh, and then, you can do this and you can do it. And I was like, ooh, these guys are interesting. Like, I would have never thought about that, which was absolutely amazing and so enriching, and taught me that there is so much value in talking to people who are not like me, because they ask me questions that I wasn't expecting, right? They push the envelope. They get me to take a step back and revalue some of my assumptions. Kind of like what I said about edge and AI, right? It's a big step back to revalue. Hey, we've made those assumptions, 50, 60 years ago. And it turns out that here is something that's pushing on the boundaries. So that's always, where that tension, that healthy tension, creates new innovations in ways that you haven't thought about. And I, obviously I'm not the only one that says this, or even SNIA. If you look at a lot of the, where OpenAI started and some of the innovation that they brought together, they have on purpose hired people with a very different skill set and so on. So there is so much value in this. Now, I want to share with you something. As a grad student, towards finishing up my PhD, I got obsessed with this concept of social networks and how social networks gets built as a graph. I had definitely an unhealthy obsession with graphs in general and graph theory as a grad student. And my advisor knew that, so he had to like manage it. He's like, okay, that's cool, but another.
He's saying like, Rita, not everything is a graph. And you're like, no, it is. Yeah, trust me.
So anyway, I got obsessed with that, and I wanted to be able to capture a social network. And there was a social network, I'm not going to mention their name, since then they're no longer popular, but they used to list on a website everybody's friends. So you would potentially be able to create a crawler. So I remember one time, I was just like many grad students, right? You geeking out with a bunch of other grad students in the lab. And we're talking about it. And one of them said, well, that would be a lot of work. And as is my custom, I took this as a challenge. And I turned around that afternoon and I, by Saturday morning, it was like a Friday afternoon. By Saturday morning, I actually had a crawler that was able to crawl that network. And I crawled that network, and it was roughly around 2 million users with their interconnections. There were a lot of exciting things that I learned along the way. But what was fascinating is I started drawing pieces of that graph. And what it showed, every time I would take someone, let's say I took you, Eric, and you're the center of your own universe, and I would draw, your friends, and then your friends' friends and your friends. So I would do, n equal 2, 3, 4. And what I would always get are these awesome looking flowers, and that had things like almost petals, but then some of the petals had connections. I was like, what the heck is that? So I dug a little bit deeper, and I found that most people have few interests, and each interest will immediately bubble either as one group or multiple groups with what we call cliques, right?
Right. Yeah.
Highly connected group of people that know a lot about each other and friends of friends, and the friend is also friend with all the friends, and so on, right? And these are communities based on topics. And these will be like very thick petals. And then I would see thin petals. And most of these were things like family members, friends from high school, right? They're not as strong. They have other interests. They don't have as many affinity to each other. And then every now and again, these groups will have some connectivity between them that the social networking community calls bridges. Right. So let's say you are interested in golfing and playing tennis. So you become that bridge between the golfers and the tennis players. And then there will be communities that are completely separated, that have no connection whatsoever. And these were controversial topics. Things related to politics, without going into the details, you can imagine. And it was fascinating to me. And I plotted several individuals and did some analysis on them. I never published that work, by the way, because my advisor was hustling me to graduate, which was fine. No regrets there. But it was interesting seeing the diversity as a graph, right? The people who are interested in very different things, and how that not only reflected on them, but it reflected on their network, and how they became a stronger bridge if they were interested in things that are very different from each other. And that like made this whole concept of, interest and diversity of skill set even like put a picture on it, which was pretty darn cool.
And I think that is the wonder of what we have. We've been given so much capability with innovation and technology. And it's funny, I sort of started off thinking we would sort of go back in the Wayback Machine talking about, HPC and which then sort of had multiple waves that is now sort of cool again because we call it by a different name. But in the end, to go to this very thing that we talked about at the start, the thing that gets you to the thing, that's it, right? Is that we're not here to discover the things we know, but to find the edge cases and find those anomalies, and then realize that those are not as anomalous as we believed, and that there are patterns to the anomalies. And in fact, now a different way of measurement and prediction, as you say, is the sort of the buried lead of LLMs is that we believe that it's like it can complete a sentence, it can write a paragraph, it can write a blog, it can write a book. But in the end, it's like, how and why does it do that? And then we take a look at the other applications. And then what allowed us to get here is, as he said, it's hardware, software, people, innovation, breaking barriers. And in fact, I think the acceleration now, this flywheel effect is incredible because like you said, we're going to use AI to build AI. Like we never had that before. We wrote on paper. I've got a friend, he said he was a student of John Nash, and he says, amazing thing. He's like, we used to write our code on paper and he would just look at it and go, wrong. That he was your compiler. And because you had to find somebody who was that good to be able to move that fast. But now I can just pick up a phone, I can download an app, and I can be that fast.
Oh, absolutely. And think about what that would do for innovation, right?
Right.
Because only the people who were able to write code on paper that would pass the John Nash test were coding. So now the entire world can code with prompting and bringing their own creativity and personality. Think also about the innovation when it went. I remember the days when you had to be someone who can write code in C or even Java to call yourself a developer. Yeah. And then this happened, right? And everybody were writing apps, and gosh darn it, apps that they write are so much better than the apps that I would write. Because my running joke is that I'm an engineer. If you ask me to give you an interface, I'll hand you a command prompt or a Jupyter notebook. And nobody wants that from me. But imagine all the creativity and the awesome apps that people have come up with. These are not your C++ developers, and thank goodness for that. So now we're even opening the aperture more, and it's going to be super exciting.
It's a beautiful time. I always say every day is the greatest day to be in the industry we're in and in the world we're in. There's obviously plenty of challenges in the world, and there's plenty of challenges in technology, all of which are being advanced and dealt with and thought about and acted on by amazing people like yourself and your team. And so, Rita, I could literally do this all day. I'm only saddened because we don't have enough time to keep going. But yeah, let's chat more for sure. And for folks that do want to connect with you and
yes,
and learn more about your work and maybe, obviously among SNIA, we got lots of opportunities to connect to folks through that way. But what's the best way to reach you, Rita, to find out more?
Yeah, you can definitely find me on LinkedIn. I have such a unique last name. It should hit just me. But I'm also Rita.Wouhaybi@Solidigm.com, and would love to hear from everybody and geek out and collaborate.
Fantastic. Yeah. As somebody who is the most common name ever, this is how I ended up with Disco Posse as my moniker, because Eric Wright is Easy E. There's an author in the US, an author in Canada. There's a football. If you look up Eric Wright, I'm like the 19th page of results. But if you look up Disco Posse, that's it. Yeah, there's only one of those.
Fantastic.
Rita, thank you very much. And again, for folks, definitely check out the work that Rita's doing both in and out of the SNIA community and all the amazing stuff. We've got lots of great podcasts like this with amazing people of interest and folks that you can meet as well in person, because I've got events like SDC, the Storage Developers Conference. And I'd say it actually should be SNIA Developers Conference and Innovation Developers Conference. It is so much more than just storage. So let's check out more. And we've, of course, got the audio version of this podcast, and there's a video version. If in case you're listening and you want to see all the cool stuff that we're talking about, you can see it live. Head on over to the SNIA YouTube channel. So thank you very much, Rita. It's been a real pleasure.
Take care. Bye-bye.
Thank you for listening. For additional information on the material presented in this podcast, be sure and check out our educational library at snia.org/library.